Q in is very simply this stroke right along here. That's the only place heat flows into the system, is in that first isothermal expansion. But here's the claim I want to make now. The work out is simply going to be the difference between the two. It's going to be the net, NET, the net heat flow, which is the difference between the two. Let me put down Q in plus Q out. And recall, of course, this is going to be negative. On my notes I said negative y. I know it's going to be negative y. What, and let me put it this way, what physical argument would I use to argue that Q out will be a negative number? Ignoring that plus sign, the Q out is going to be a negative number. What argument would I use? Can you think of it? It's just that it's work done by the system. That's how the Q comes out. So it'll be that Q out happens while we're compressing the system. Work done on the system, I said by the system. Work done on the system, and that same amount of work then gets rejected into the reservoir. So it is heat out of the system. It will be negative. All right. What did I write next? I said Q in equals QAB, and Q out is going to be QCD. And let's use those now just to write down the Carnot efficiency. E Carnot is going to be the work done, Q in plus Q out divided by Q in, which of course is 1 plus Q out over Q in. And work is going to be Now I want to talk about, I want to be able to get QAB and QCD, but I'm going to claim that work AB equals QAB. And what physical argument can I use for that? The same isotherm, no change in internal energy. Since it stays on the same isotherm, of course, whatever work is done along AB, the same amount of energy flows back in to the system. So, of course, I just put down no delta U exclamation point. Okay. So, of course, you remember that work isothermal is equal to the integral from the initial to the final position of P of V dV. But since it is isothermal, it turns out to be P initial, V initial, times the ln of V final divided by V initial. And of course, P initial, V initial is going to be NK T, and in this case, it's T hot. It's the temperature of the first reservoir, T hot. So finally, work AB, which is Q AB, is going to be N K T hot ln of V B over VA. VB over VA. Yeah, that's the stroke that we're on. We're on from A to B, so the delta V is this volume minus that volume. Lovely. Well, then by analogy, Q CD must equal N K, except this is happening at the cold reservoir, T cold times the ln of VD over VC. Okay, good. We're just about there. We've almost got the relationship. What we have is that the Carnot efficiency now, E Carnot, is going to be 1 plus Q out. Q out is the one we just calculated here. Here's where the heat is rejected. N, K, T cold, Ln, VD over VC, divided by Q in, which is the upper one there, N, K, T hot, Ln, VB over VA, like that. Of course, in common, we've got the N and the K, so we can cancel those out and simplify things slightly. Carnot efficiency 1 plus T cold, T hot, Ln, VD over VC, Ln, VB over VA. However, what if I write it like this? Just watch this and see if it's justified in your mind. The efficiency is 1 T cold times Ln VC VD over T hot Ln VB over VA. Is that justified? What did I do and how did it happen? Aha! I heard 2 of you say it and you were quite correct. Yes, you can do that. If you flip this over, it introduces a negative sign. Okay, that's nice, but did it help us very much? No, not yet, but I'm going to fix it all up real good right now. Because you see, I can simplify further by noticing, of course, all of these points are connected together either by isothermal processes or adiabatic processes. Would you agree with me that B to C is adiabatic? P, B, B, B to the gamma power, P, C, B, C to the gamma power. Also, D and A are connected by adiabats. So, P, D, B, D, gamma, P, A, B, A, gamma. So that describes those 2. There are 2 other processes, both of them isothermal. Since they're isothermal, you'll notice A to B, an isotherm. So it's going to be P, A, B, A equals P, B, B, B. And also the other isotherm is C to D. So C, C, D, D. So now we have described all 4 strokes and put the 2 adiabats together and put the 2 isotherms together. So all of those things have to be true because we've got this simple cycle of nothing but isotherms and adiabats. Well, the next thing is, of course, just multiply the 4 equations together. Why? You'll see in a second. So if we multiply them all together, it's going to end up looking like this. This is going to be kind of long, but it's fun. P, B, B, gamma. P, D, B, D, gamma. B, A, and B, C equals this product over here. PC, BC gamma, PC, BC gamma. Next one is PA, BA gamma, PA, B, A gamma. Now B and D. Where's it? B, 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 P, what's the last one? D, B, D. What fun. But there is a PA, a PB, a PC, and a PD in common, so we may drop all of those. we may cancel those out. So now, easily simplified, V, B, B, D, B, A, B, C equals B, C, B, A, B, B, and B, D. But you'll notice, VB to the gamma, VB. So I have a VB to the gamma minus 1. So now, just so I stay, I've used these, so I'm going to cancel them out. Okay, what's next? VB. So I have a VB and a VD. A VD to the gamma, a VD over there. So VD gamma minus 1 equals, so the D's are gone now, this one's gone, and this one's gone. Aha! We have a VC to the gamma and a VC here. So, on this side, VC gamma minus 1. And finally, we have the VA. VC goes like that. And VA. Like this. So now we've used everything up. Lovely. I guess we can get rid of the engine since nobody's going to actually build this engine. It's going to be in theory like that. And with one eyeball over here, look. With one eyeball over here, I can say VC, VD. So we have VC to the gamma minus 1 over VD to the gamma minus 1. So that takes care of these two. This one's gone, and that one's gone. And on the other side, we have equals VB over V, what, A, to the gamma minus 1, gamma minus 1. Which says, of course, if VB over VA to the gamma minus 1 equals VC over VD to the gamma minus 1, then, of course, VB over VA must equal VC over VD. And if that's true, then Ln of, what's on top? VC. VC over VD divided by the Ln of VB over VA must equal 1. Hence, therefore, we conclude that this cancels to 1, and we get the efficiency of the Carnot cycle as 1 minus T cold over T hot. And there we have the efficiency of the most perfect engine we can possibly design. There's the Carnot efficiency. It depends only on the ratio of the temperature reservoirs, the temperatures of the two reservoirs, the cold reservoir to the hot reservoir. Now let me give you an example, kind of a humorous example of how this can illuminate things. Let's, for example, imagine, and this used to happen in the middle 1970s, right after the first oil crisis. People would claim that they have designed a 100% efficient machine, a 100% efficient engine. Of course, that sounds wonderful because as soon as the price of fuel went up, everybody was concerned about how much fuel do we have left. We must use it efficiently. And a typical automobile engine had less than 30% efficiency. So if you claim 100% efficiency, you've got an engine that is more than 3 times as efficient as the existing. So here's your opportunity to invest on the ground floor. I don't have enough money to manufacture this engine. I've got it designed. And all you have to do is give me $10,000 and I'll build an engine and we'll make a fortune. We'll make an absolute fortune.